Hi, Stuart here. Today's topic is Container Readiness Checklist. This talk is aimed at .NET core developers, but it will pretty much cover off on topics that apply to all stack types. This is a super high-level overview, and future videos will drill down. In order to figure out if your software products or aspiring software products, if you're doing a Greenfield thing, you need to cover off on a set of evaluation areas. Each is got prerequisites to the other. And if you get to the end of this chain of evaluations and you do some testing and it works out, then the answer to the question, am our team container ready, is yes. And if not, you may want to think about it. So let's start with some basic code quality things. And again, I'm focusing on .NET specifically, but I really want to point out that there are variations of these basic code quality tools that apply to any stack. So if you're a .NET developer, I'm going to assume you're in Visual Studio or Visual Studio Code, which means you have all these things available to you. So you want an editor config. And I have a link to a suggested one in the footnote, and you can go out to my GitHub and pull it down and modify it to suit your needs. GitHub, the folks who wrote GitHub have a NuGet package called Security Code Scan, relatively new, but it does find security problems in your code. And of course, Microsoft Code Quality Analyzers, which are the most effective if they're new, get it into your package, but you can run them as an add-on to your Visual Studio. But again, I strongly recommend that these be a standard part of all your projects, and that any code that needs quality and security analysis, so not testing code maybe, benefit from these kind of scans. And as you run these, right, as developers, you're typing along in Visual Studio and you correct the light bulbs that pop up in the left-hand margin that tell you that what you've done may not be optimal and you should look at it. In many cases, it will offer to correct your code. And as you do that over time, you'll get to be a better and better developer. Now, I'm not going to say that these are going to find everything, but they're a heck of a good start. And at a price of free, you can lift the coding quality of all of your developers, including your QA that write test code, up considerably. The other thing is testing tools, right? And Magenic and most enterprise organizations focus on a concept called risk-based testing. So we look at our use cases and user stories, and we want to make sure that the most critical ones have the most testing attention. And the ones that are perhaps less important maybe don't need an automated test. The rubric is, and we'll talk about this more later, that if something can only be manually tested, either you haven't thought through enough how to test or have the right tools to test, or there's something significantly wrong with your code because it fails the criteria of testability, which is an important non-functional requirement. And so, there are some basic things you can do about making sure you get code coverage and things. And if your team has the wherewithal to buy tools like Endepend and Veracode and SonarQube and on and on and on, commercial tools that cost commercial amounts of money, you can even raise your code quality bar even higher. But the dearth of those tools doesn't mean you can't aspire to high code quality. What it means is that it may take you a little longer or be a little harder, but in general, it's a mindset, and it's not about the tool. It's about the humans using the tools to create business value out of code. Stability is the next big thing. And by stability, what I mean is the holistic 360 viewpoint of stability. So not just the usual tropes of memory leaks and resource disposal and, bad runtime practices and doing caching in your process runtime space, memory space, and things like that, but also stability in terms of your product over time, right? One of the main KPIs that we use to assess stability of a system is whether or not the rate of bugs opened and bugs closed is a relative constant to each other. If we start to see that the bugs opened outdistance the bugs closed, then that's a sign that we need to stop adding features and do one or more stabilization efforts until those lines coincide again. And then as a project mantra, we want to manage the risk of our project by managing to that and other KPIs. And I'll point out that going to enterprise level systems, of which the cloud and containers as a subgenre, so to speak, of the cloud, that DevOps is table stakes. And if you haven't read Gene Kim's excellent book on DevOps, I strongly recommend it. We have other DevOps videos you can look at as well. And these are sort of the minimum components of a good DevOps program, right? We need pipelines, we need infrastructure as code, we need monitoring, logging, and awareness. And all of these things allow us to either increase stability, measure stability, or manage instability, which manages risk. I want to take a second and talk about composite testing for a minute, because at the top of the CMMI capabilities ladder, so to speak, is an efficiency that comes from effective reuse. Reuse being the holy grail of computer science in a lot of ways. And if you're a .NET developer, making your own NuGet packages to share among the teams is one way of getting to reuse. But I'll point out that well-crafted test stacks written by different stakeholders that are reused all the way up through synthetic transactions that run against your production system are one way to gain efficiency as well as allowing you to increase the speed of innovation. And you can do that as long as you're not trading off your risk-based testing program or violating one of your other KPIs, like the rate of new bugs discovered to bugs resolved, and so on. We'll do a video on composite testing. I want to revisit the 12 net factors because these apply to any enterprise endeavor. Any piece of software with more than one deployable unit really needs to think hard about the 12 factors. And of these, the Fast 5, upon which we've done a number of videos, are critically important for success in the cloud and are absolutely gating factors to have success with containers. And I should say that it's our observation that moving to a cloud, any cloud, and moving even more nuancedly to containers acts like a microscope and magnifies anything that is ill-considered or poorly implemented or unstable and amplifies those effects. So if you have something running in the data center and it's kind of sketchy, if you move to the cloud, it'll be sketchier. And if you try to containerize it, it'll be even more sketchy than that. So thinking about maturity as you move your software system into more and more nuanced instances of the cloud, starting at infrastructure as a service, so just VMs, like throwing your software on VMs. That requires a basic set of skills that are identical pretty much to deploying your applications in your own data center. If you go to platform as a service, software as a service, function as a service, application hosting as a service, and so on, you pretty much have to climb that CMMI maturity ladder at least a couple of rungs. And if you're going to go to containers, you pretty much have to go through most of these. So revisiting the Fast 5, and again, we have a video on this. You need to make sure that your DevOps spaces are covered, and you need to make sure that the big three changes to your software, configuration, disposability, and logs, are all handled well. I want to rest upon disposability for a minute because it's probably the single most challenging thing when going from hosting your software on infrastructure as a service or platform as a service to hosting it in containers. A virtual machine generally takes seconds to power down, and in the process, your running code has time to finish units of work and do an orderly shutdown. In many cases, especially in .NET, you can listen for those events and actually cause your software to shut down in a tidy way. But in containers, a container can just ephemerally stop being there. And what this means is you need to spend a lot of time thinking about units of work and the restartability of units of work. And we have a lot to say on the unit of work pattern in other videos. But understand that probably the most challenging thing that happens when you go from hosting something in, for example, Azure Application Service to hosting it in, say, Azure Container Service is that the shutdown time of your applications is going to go down dramatically. And this is good and this is bad. The bad part is if you're in the middle of processing something, if you were hosted on PaaS or even on a VM, you probably would have had enough time to finish the processing you were on and then respond appropriately to your code shutting down. In a container, though, that opportunity is much, much shorter. And so things that seem to run stably and behave well, and you do HA tests and you do DR tests and you're starting your VMs and stopping your VMs and everything looks hunky-dory and there's no loss of value. What happens when you go to containers is, and you repeat those tests, is that you get a different outcome. So spend some time on disposability. And then, the chestnut of running anything in the cloud is you want to externalize your configuration so that you can build once and deploy many times, and that you actually emit logs that are useful. Because the more over there your code gets, and containers are definitely over there, the more you need to have insight into what's going on. And again, if you're running on a good cloud vendor's platform, and again, I'll pick on Azure because I know it the best, but the other cloud vendors offer morally equivalent things, that you're going to get insights into your running process from the base operating system you're running on, from the runtime of your platform, so the .NET runtime, and then lastly, and most importantly, what your developers need to do is make sure that your applications emit logs that are useful in figuring out what's going on, and your platform will do a job of aggregating and helping you analyze those logs but they have to be there for you to analyze. So I'll just stop and say that if you've done everything up to this point, that your software will probably run well anywhere, right? It'll probably run well in your data center. It'll run well in VMs up in the cloud and platform as a service up in the cloud. You know, you've done a lot of the work it takes to climb the CMI ladder and have solid DevOps, operable code, stable code, reasonably bug-free code, right? We want to drive down from 5 bugs per 1,000 lines of code down to as close to 1 or 2 as we can. That if you do those things, your software is good to run pretty much anywhere. So what else do we need to do to be container ready? Well, team training is the big thing. First of all, I can't emphasize this enough. Get a vendor-supported container system. Yes, they're open source. You can bring them up DIY, but unless you have hired people who have done that before and know how to build and operate a container cloud, you're not going to be happy. Plus, you're spending money on things that you could be pouring into innovation. So using a vendor-supported container hosting solution like Azure Kubernetes Services or Pivotal Kubernetes or one of the other great Kubernetes curated, operated, and fairly bulletproof implementations is an investment worth taking. And why is it under training? Because surprisingly, a lot of shops have a not invented here thing, and they don't want to take a dependency on a vendor. They see containers as a way to become vendor independent, and to some degree, that is sort of true. But the truth of it is that it's very hard to get to the 100% milestone on that. And so instead, you're weighing, as a matter of training, the risk of getting locked into a particular vendor's solution or solutions versus the cost of 100% DIY, and there's no throat to choke but your own. And let me just say that while containers superficially look fairly easy to use and adopt, that DIY, especially on-the-job training, is not a good way to do container systems. And if your shop is not capable of shipping software on the required quality bar at the desired business cadence, and here I would say if you can't monthly ship to production or better, that's a huge red flag before climbing up that cloud hill. In terms of training, you need to make sure that your developers and DevOps folks, and a little bit your QA and BAs and project managers, but really the people who are hands-on in the creation of these systems and management and operation of these systems really get serious training. And if the vendor offers training, and most of the serious vendors do, and by the way, that's a criteria for deciding whether or not to adopt a vendor. One of the first questions should be, what's your SLA? Followed somewhere down that list, at least in the top 10, is what's your training program look like? What do you have for training resources for my different roles? And I'll point out that above and beyond platform and container-specific training and vendor-specific training, that if your people aren't well trained in the basic tool set they're building with, in this video it's .NET Core 3.1 long-term support, that they're probably not going to be able to sustain success even if you have initial success. In other words, a failure to have adequate training of your developers and QAs and DevOps people may gain you a short-term victory, but the value of that program will drastically erode over time in the form of outages, embarrassments, critical bugs, and in a worst case, something that makes the front page of a national newspaper. So don't skimp on it. And lastly, I just want to throw this out here because containers, like everything else in computer science, is a useful set of patterns and practices for which there are use cases and anti-use cases. So before you adopt containers just because they're cool, you should make sure that you have considered potentially easier ways of implementing your business problem, and that before you invest in containers and go through all the effort to raise up your quality and stability bar until your code is suitable to even run in containers, you need to consider the economic and risk trade-offs involved. I'm not anti-container, let's be clear. I help a lot of customers be successful on containers, but they're often surprised about how much additional initial effort is required, and the payoff is always downstream in higher densities, the ability to scale more agilely and nimbly and in better scale units, in having software that is really durable because it was built for containers, and so it handles unexpected unpleasantness well, right? All of those things pay off. And if done correctly, you can gain business velocity and business agility, and those things are serious market differentiators and worthwhile. But you can get to those goals without having to use containers. It's just that containers are seen as a way to get to some next level. But like any other ladder, it's useful to climb the rungs one rung at a time for safety's sake, if for no other reason. So, last thing. You need to do a serious test. Not a, let's try it for 1 week and see what happens before throwing ourselves fully into the development cycle. Right? They need to, if you have an existing application, you need to deploy it and then beat on it, right? Do all the things you would normally do. HADR tests, performance testing, functional regression testing, security penetration testing. And you should know in your new hosting environment, whether you're going from your data center to a virtual machine or going to PaaS, how are you going to version it? How are you going to patch it? How are you going to have network and system security? And, what about my governance program needs to change? And your governance program, as you climb the cloud hill, will need to change. And the primary change for successful organizations that adopt containers is automate virtually everything except human approval. My name's Stuart. Thank you for your kind attention.